from this wire until to the laptop, it is not like one line plus or minus. It is a sine wave. Okay, the AC power is a sine wave. In 1 second, 50 times it is fluctuating. Okay, that is 1 second is happening. The power from this adapter until to the laptop. Okay, if any disruption over there, then immediately the power cut off over or power disengaged. It's very simple to say thundering. Normal striking happen, your TV signal, even your images slightly change. Okay, it's a fraction of a second because thunder also happening in a fraction of a second. If the signal get disrupted, your screen will be disrupted at a fraction of a second. If it is even more longer, mean like it can be 5 seconds or 10 seconds. Okay, that is all because all is waveform. Okay, so even power signal is all waveform. Okay, power depends. Okay, kind of voltage 230 or it can be a battery voltage like 1.5 volt, 3 volt, 9 volt, anything. Okay, one signal is based on power, the other signal is based on data. Okay, no power over there like internet, Wi-Fi. It doesn't have any power on it, but it's a signal. Okay, data transmission. So all our internet is all data transmission, but no power on that. Okay, that's why Wi-Fi. If you scan this room, you can able to see a lot of waves is around us actually. Okay, but it is not harming us because the wave is very big actually. Okay, it's simple to say. Sometimes if you are closed room, your phone signal drops. Okay, instead of like 5 tower, it can be 4 tower or 3 tower. Or it's simply to say you take your phone to go to the basement or basement 5, level 5 basement down, signal cut. So basically the signal even cannot cross through all the floors, even though a lot of doors and everything, even open space is there, but cannot go even deeper. So startup, signal is weak compared to Singtel. Okay.
Intel also now was ready.
Yeah, you can say that because everybody on same boat,
Yeah.
fiber optic. Okay, but even though Singtel lay the cable, startup using it, but everybody now is on the same boat. But last time startup is too weak. Now Singtel also M1. Maybe you can compare with M110. Okay, or
M1 cannot.
worse.
Worse.
No need to ask. How about My Republic?
My
My
No way
Republic is
better.
just on internet only.
Singtel okay lah.
Singtel okay.
Singtel still
Expensive
better.
a bit, okay lah.
But actually, that is what you can say signal strength. Okay, tower strength. The signal is not coming. That's why we can say, oh, this is not good. This is good because the moment you are seeing, it is not smoothly happening. It is a draggy kind of thing actually. That is very simple to say the response as per picture what we are calculating. Okay, B is the response on it. Actually, it has to go until like this height, but what you get it lesser. Okay, if it's so less, then gone already. Okay, but mostly we are trying to boost up. That's why every congestion location they have a router. Everywhere is router to connect it. Otherwise, it cannot work actually. Okay, so even though you say 10 Gbps gigabyte per second data transmission speed, but connectivity router should be there. Then only it will be sensible. Otherwise, no sense on it. Okay, maybe that particular area, yes, that particular router location, okay. When you go 3 meter away, then you won't get it. Okay, so you have another router. Unless you don't have any wall restriction, then it's okay. It will be acceptable. Okay. Usually signal can go until like 10 meter. If you say from here to until to that room, this is like a very straight room, okay, still can be able to get it. Okay, so it also depends on the material. Like you have like glasses, it scatter the waves actually. Okay, so that is various reasons. But what I'm coming over here, practically what we are speaking, and now we have like a symbols or things we are trying to remember is nothing but pi and the B. Okay, the formula is over here. B is amplitude, sine waves, omega t with respect to time, and phase is the shift. Okay, So this waveform, I want to make it as a plot. Okay, there's two types of plot we are doing it, and this kind of domain we call frequency domain. Like how many frequency I'm doing it, how many sine waves is happening. When here one thing, a wind speed, kind of turbine is rotating, wind turbine. Okay, when the wind is too much, obviously tower displacement is happening. Okay, it is always calm over there, but if it's on a high uncontrolled, then it's like very peak. Okay, from the signal you can understand whether it is conditional okay or not okay. So come to a mathematical expression. We already know about the transfer function. We are trying to relate with the B. B is nothing but amplitude based on the sine waves. What is the height of that wave actually? Maybe just show back. And this is B. Okay. So we are trying to get the first order system and a phi angle that is can be manually calculated. Okay. It's nothing but different omega you can substitute based on your choice. Then you can get different B and different angle. Okay, so based on these two input, you can make a plot on it. It can be manual plot or it can be using software. So what you are trying to do is response amplitude B or phase phi of the function. When you draw it, maybe individually you can plot. Let's say we are plotting for B, so B on vertical axis, and this is omega. Okay, then the other one with the angle on vertical axis, then omega. Two different plot you can draw it. There's one way to do it. Instead of like two ways to do it, you can combine into one plot. You can have both information. So in that sense, H is over here. H they will get back. That is called amplitude ratio. Okay, when you divide by the gain, then the rest of the formula will be there. So instead of like omega supplying, you get amplitude ratio and phase angle. Okay. Here there is a formulas for amplitude ratio and phase angle, and this entire topic 4 we are going to use these formulas. Okay. If you want to do manually, okay. If you are using software, the software already know about this formula. No need to do anything. Just call bot plot or polar plot. You know how to draw it. Okay. So, but some of the question will ask like manual, but let's go through it. Okay, first is first order system. That's a formula for amplitude ratio and phase angle. Okay. What is on the polar plot? If you want to draw a curve, let's say this is the point I want to make a point on it, which is how to do it. The length is so-called amplitude ratio, and that is the angle will define that particular point. Okay, let's go back over here. Let's say now 0 degree, 0 omega. You will get like amplitude ratio and you will get like a phase angle. These two value will be getting in, okay, for 1 omega. Okay, based on amplitude ratio and omega, I will make a line with that angle, then I mark the point over here. Okay, likewise you can have multiple points, then I join all the points to get the curve. Okay, that is manually if you want to do it. Okay, so even the software doing the same thing in a fraction of a second. It does the same thing. That's very simple. Over here, first order system amplitude ratio. The line is nothing but the length of the amplitude ratio, and the phase angle is nothing but the angle that defines that omega point. Okay, omega 0, omega 1. Omega 0.1, 0.2, likewise you can have multiple points, then you join all the points. Okay, so that is okay. Basically, first order system, the curve is coming on the 4th quadrant of the graph. Okay, now this is a graph, first quadrant, second quadrant, third quadrant, this is the 4th quadrant. Okay, so it is start and end inside the 4th quadrant itself. Okay, first order system. Okay, first order system. Whereas second order system, it will go 4th quadrant as well as 3rd quadrant. Okay, so still the same thing. Let's say giving an example, this is my omega equal to 5 means my amplitude ratio is 1.11 and the pi angle is 33 degree. Okay, so end up I have 1 point. Likewise, I have multiple points to join and to make a curve. Okay. Okay, let's talk about the first example. This is our transfer function. Okay, so we know it's very simple, like 3, 1 plus 2d, which is the transfer function. Using the formula for amplitude ratio, we can able to write this way, and the only variable is omega. If you substitute the omega, you will get the amplitude ratio. Okay, and again the phase angle also, you just put phase angle, and that is end up like only omega is there. Okay. So now I am having that amplitude ratio and omega formula. Omega only is need to be substituted. Let's say I am substituting 0 value on this formula. So in the 0, the value is going to be 0 over here, end up like 3. Okay, and the 0 value I substitute over here, tan 0 is 0. So end up like the value is 0 over here. So likewise, we need to substitute multiple omega values onto these two formula, then you get this entire tabular column value. Okay, understood? A copy? Any questions? This is a tedious process to substitute different omega and calculate one by one using these two formula, then fill up the entire tabular column. Once you fill up the tabular column, then you can start to make the graph. Okay, not this one. Make this graph. Okay. So you need a protector, a ruler. Then only you can have an angle to measure, make a line, and you can mark the point. Okay. It is a tedious job. Okay. So that's why the MATLAB coming in. Very simple, easy. Okay. So so basically it is polar partition for first order system. It is in 4th quadrant, which is highlighted over here. And let's put it this way. Based on this transfer function, I'll get the amplitude ratio. Okay, based on the formula where t is nothing but time constant, k is nothing but gain constant. So k equal to 3 and t equal to 2. So you get the formula with only term of omega. Next, phase angle, again the same thing, with time constant substitute, you get the phase angle formula. Then substitute different omega value onto this equation, you get these two tabular column values. Using this, you can make a graph manually. Okay. So now I want to do it using MATLAB. Okay. So how to do it? Now we already have a program. You can look. You already upload this folder in your MATLAB. And example 1. Just double click. It will open the file over your screen. So we just say like 3 is the numerator, yes, numerator 3, and we have denominator 2 and 1, yes, and we got the transfer function, numerator versus denominator, okay, that I assign to one of the variable called system, okay. Then I call a name or library, which is to draw this polar plot, is called Nyquist. Okay, Nyquist is the library. Okay, you call this variable over inside. That's all. It automatically make a plot. So of course, it is not only drawn on the 4th quadrant. It also draw on the 1st quadrant. Okay, it's like a mirror only. Okay, so you run it. I mean, once you load, you just run. Once you run, you can able to see numerator, denominator, and the system function. 3 divided by 2s plus 1 is already there, this transfer function. Then it automatically plot the graph. Of course, you can take a look. Let's see. Open bigger window. You can draw a bigger screen. I can make it bigger. Then I can even point the arrow point, then we know what is X and Y on that particular point where I'm clicking, then we can get all the points. If we look, obviously, it starts from here all the way to the 0, and it is a reciprocal on it, okay? So you can download with what we are currently seeing. You can customize your graph, and you can do all kind of things. But anyway, we'll close this one first. So everyone got it? Any errors? Any questions? Are we good? Okay, so likewise, it's just like a library to make the polar plot, Nyquist. Why they call Nyquist, later will come on it. Nyquist is to say whether the system is stable or unstable. Okay, there's a rule to identify whether the system is stable or unstable.
假的。
Okay. Okay, question. So we already done. Even though if you want to do manually, yes, you can try. Okay. And if you ask me what is the omega value you need to substitute, it's your choice. Okay. You can start very simple. You can start with 0. That is a common one. From there, you can fill any number. Okay. So I can put it 10 or 100. It doesn't matter. So you will get the respective amplitude ratio and angle. Is how to determine, very simple. This one, as long as get minus 90, I think it's okay. Okay? Because it is the point when you say 87 degree, this is 87 degree. Okay? So 90 degree is the maximum. Okay? So even you can put 20, I believe maybe you can get 89 or something. So that is the only thing, because we see this length is smaller, how to do on the ruler. 1 mm can do 0.15, you cannot really do that. Okay, you cannot really point it actually. Okay, unless you have a graph paper, yes, you can do that actually. Graph paper, then you can have a segregation, you can point it actually. But as long as when this amplitude is lesser, I don't recommend to try a big number. As long as, I think this is okay already. 2 is already 1.2, yes, I can use the ruler to at least put 1 mm. Okay, even though 76 still okay, somewhere here I can directly join line. You don't need to be so accurate to get until to the point. Okay, questions until now? Okay, so similar pattern for all the 9 exercises. Okay, so I've given 9 exercises, and this is again second question, mechanical system. Whereas we are now interested more towards like our amplitude ratio and things. So if you substitute, yes, you can get it. Say now here, if I substitute 10, I can see 0.71, 45 degree lines, you can get it. But based on your substitution only, you can decide whether you want to go more or less. Depends on the transfer function. It's like a trial and error. Let's say now this point, omega 0 is this point, omega 2, omega 5, okay, then omega 45. So that is the length and the angle, you get that point. Okay, likewise.